The goal of this lesson is to graph a function using transformations when the graph of the original function is given. Now this is basically a review of previous lessons, so you can treat this as an activity where for each graph you attempt to try it yourself and then look at the key as we move forward. But the information given in all these transformations are from previous lessons, and so from previous lessons we looked at this diagram, and so we talked about function notation. We talked about what each of these function notations meant in terms of types of transformations and how the points are changed as we go through each transformation. And so we're going to continue this process discussing this, and at some point through the end of this, and this will probably be the final one, you should be pretty confident with the lessons dealing with transformations. Okay, so we're going to look at the first graph, and so the direction says that the graph of the function g of x is shown. So this is a function g of x. And you want to use this graph to graph f of x, capital F of x, which is g of x minus 3. So recall that if, now remember this is your, let's say your basic function, your original function. So that's the original function right here. You want to take this original function and remember what this means. So think about what this means. So from previous lessons, all the activities you've done, what does subtract 3 from your original function do to the graph of the original function? Okay, so think about that, and if you need to go back and review something, go back and review something, but hopefully at this point you know what it does. So basically what it does is it takes every point on this graph, every point, and notice the arrows here, every point, and it shifts it down 5 units. Okay, now remember, what does it mean to shift these points down 5 units? What changes? What coordinates changes? Do both change? Does only one change? And so that's what we're talking about here. So when we shift down, vertically down 5 units, that means that the y coordinate is being subtracted by 5. Okay? So that's what that means. But you really don't have to know anything about the y coordinates because all you're doing is knowing that you're shifting it down 5 units, right? So what I would do is I would take some points on each of, and these are all segments here, and well, obviously these are rays right here, the one with the arrows. But you have 2 segments and 2 rays. What I would do is see where these two meet right here. I would go ahead and take that point and shift it down 3 units in this case. Okay, I would shift it down 3 units. Okay, so we get, see the point negative 4, 4, negative 4, 4. When I shift it down, 3 units, I get 1, 2, 3 right here. Then shift this one down 3 units right here. 1, 2, 3. Then shift this down 3 units right here. 1, 2, 3, and you're done. So basically all you do is just remember this right here does not change the shape. Because the only things that change the shape of a graph would be your vertical, horizontal transformations, vertical stretch, vertical shrink, horizontal shrink. This is just a translation. So what I would do is I would just go ahead and show that the rays just like it is, except everything's been shifted down 3 units, just like this. And so do the best you can. So there's that one. So I'm doing this in blue. So notice everything is shifted down 3 units, and that's it. That's all you do. That's all that one is. So you just finish up the graph and you go on to the next problem. All right, so you just have to remember those properties about translations. And don't forget the arrows, and there you go. So what I would do, though, is I would go ahead and label this f of x. I would say this is f of x. And remember, I would go ahead then and say this right here was g of x. I'm sorry, a lowercase g of x. Okay. All right, and that's it. So you can tell, look, everything shifted down the same amount of distance, right? That's what translation is, the same distance. Okay? Same distance either down or up, left or right, same distance. Okay, so that's the first one, so we'll call this number 1. Okay, number 1. All right, then number 2, we have this. So number 2, we have the graph of g of x. So this time we have g of x. It looks like this. And you want to graph k of x. Now remember, the difference between this one and this one is that the number is on the outside of your function. So that's a vertical translation. So remember, when it's on the inside, that's a horizontal translation. And remember, when we talked about that, you got to think counterintuitive. All right, so you don't move it. When you look at this, you see that -2, right? You don't move it 2 units to the left. Remember, you got to think counterintuitive, so it's actually 2 units to the right. So every point you just shift 2 units to the right. Now there are some curves here, so it'll be a little bit more difficult to graph, but do the best you can. So remember, all we're doing is just shifting every point 2 units to the right. So remember, that's this right here. This one right here. So you're shifting 2 units to the right. All right, so what changes will be the x-coordinate. The y-coordinate stays the same. And so you're just shifting 2 units to the right. So we're going to go 1, 2, just like this. All right. Then we're going to go 1, 2, just like this. Then take this one as well. 1, 2. So do enough to where you can figure out what to do. And let's go ahead and use this one here. 2 units to the right. 1, 2. All right. And then this is a curve right here, and this is a curve, and this looks like a ray. Just do the best you can. All right, so it looks like it'll be something like this. And remember that whenever you do horizontal translation or vertical translation, the distance stays the same. So try and make those distances the same. Now you see right here where you can actually kind of use that as well. So go 1, 2, just like this, and kind of help yourself figure out. See where here W1, 2 about right here, 1, 2 about right here. Let's say. All right, so make that a curve. The distances are the same, okay, just like this. See how I make these distances that look the same? Okay, that's important. Got to make sure those distances are the same. And then you have a curve that does this, so I think this we can do a little bit better just without having to do any more points. Something like that, see that? And then this looks like a ray, so I'm just going to go ahead and just connect those points. And so I get something that looks like this. Okay? All right. So there's a graph. So that is k of x right here. So that's k of x, and this is g of x. All right. So remember what we did here. Remember our what we had to do is we had to shift g of x 2 units to the right. Okay? All right. So that's number 2. All right, let's look at the next one. So number 3, all right, so the ink is bleeding through, so let me put this page under that one. All right, so number 3, we have this. So we have that the graph of f, so this is f, is shown, and you want to use this graph to graph g of x. Now, notice that I'm combining horizontal translation and vertical translation. Okay? Now, remember our order. So we're going to do horizontal translation first, and then we're going to do vertical last. Always do vertical last. Now, it didn't matter here. To be honest with you, it did not matter here. But whenever you have either a stretch or a shrink, whether it's horizontal or vertical, you have to do this last. The vertical translation last. Okay, so that's important. So if you, in this case, since there's no vertical stretch or shrink or horizontal stretch or shrink, you're fine. You can do either one. But just continue using our rules. Just always remember, regardless, let's just do the vertical translation last. All right. So let's look at this. And so first thing I'm going to do is I'm going to shift this 2 units to the right. Okay. So we're going to take each point. So we're going to shift f 2 units to the right and 3 units up. All right, and notice I can do this right, those two things at once. Okay, now these are, see, there's no arrows here, so remember, 2 units to the right, 3 units up. Okay, all right, so we have a horizontal translation and a vertical translation. So remember, we have a horizontal translation and a vertical translation. Okay, all right, so 2 units to the right, 3 up. So 1, 2, 1, 2, 3, right here. Let's make sure 1, 2, 1, 2, 3. Okay, so there's that one. So remember, we're doing each segment. So let's do the end point here. So that's going to be 1, 2, 1, 2, 3. Okay, and let's do this one. Let's see this one right here. So we're going to go 1, 2, 1, 2, 3. Now you knew it had to be horizontal, right? So those 2 points had to be on the same level. Okay. And then over here, the bottom one, 1, 2, 1, 2, 3. It's so much easy to draw segments than just curves. And you just connect them, and there you go. You're done. You just have to remember what you have to do, though. Your translations and transformations, whatever those may be. You got to know how to apply them and when to apply them. All right, and where's the other one? Right here. Okay, and that's it. That's all that is. Now just make sure you label them correctly. So that one here is going to be g of x, capital G of x, and this is f of x. All right. So make sure you understand this part, though. You have to know this in order to get your graph. All right, number 4. So number 4, let's suppose we have this in number 4. So same thing, you're dealing with a horizontal translation and a vertical. All right, so you have a horizontal translation. You have a horizontal translation and a vertical translation, right? Vertical translation. Okay, and basically what we're going to do is we're going to take the graph F, so we're going to shift F. Now remember that you think whenever you do the horizontal, think counterintuitive, so it's 3 units to the left. So we're going to shift F 3 units to the left and down 4 units. Okay? All right, so remember, you're dealing with rays and segments, so I would just take this point here where this ray and this segment meet right here. All right, now let's look what's happening. So I'm shifting 3 units to the left. So you see this point right here, so I'm going 1, 2, 3. Okay, then we're going to go down 4 units. 1, 2, 3, 4. Okay, now let's look at this point here where those 2 segments meet. So I'm going to go 3 units to the left and then 4 units down. 1, 2, 3, 1, 2, 3, 4. Same thing here. 1, 2, 3, 1, 2, 3, 4. And then that's it, because then that's just a ray. All right, so I think we have it. So you know that this part, you gotta use that same figure, okay? So this is a ray, this has to be a ray. All right, so all you do is just horizontal, vertical translations, so the shape doesn't change at all. Is that same shape. All you do, and if you were, and I'll show you what's happening with the transparency, but you have the same shape. The shape does not change. Okay, and then where are we? Right here. Yep, right here. Okay, and then this. Don't forget the arrows. All right, so that is, we called it what, h of x, and this was f of x. Okay, all right, now let me kind of show you it with regards to a transparency what really happened. Okay, so I have this transparency right here that's the same shape as this one. Okay, so see it overlaps, And so basically what I was supposed to do is shift this graph right here 3 units to the left. So watch what happens. I'm going, and I'm going to use the vertex to help me move this. So, well, the point where those two segments meet. So 1, 2, 3. Okay? And then I'm going to shift it down 4 units. So 1, 2, 3, 4. And that's what you get. All right? So again, remember, every point on this graph, you're shifting to the left 3 units. We just used some basic points, and these are rays and segments. It was easy to deal with. You didn't have to use a bunch of points. And so again, you go 1, 2, 3, 1, 2, 3, 4. Okay? All right. So that was that one. All right, let's do number 5. So in number 5, let's see what we have in number 5. So number 5, okay, so we can do number 5. We know how to do number 5. So number 5, you're told that the graph of f is shown. So this is the graph of f, all right? And you want to graph h of x, which is this. All right, now remember, when there's a negative, you got to think reflection. So when you see a negative, you got to think reflection. Now we talked about reflection over the x-axis, and we talked about reflection over the y-axis. So if the negative is on the outside, that's a reflection over the x-axis. All right, if the negative is situated with the x inside the parentheses, then that's a reflection over the y-axis. All right, so which one do we have here? We have the reflection over the y-axis. So this is the reflection over the y-axis. Okay. All right, so that's what this one is, y-axis. All right, and so again, we're going to just look at certain points, since these are raised, since these are all segments. So I'm going to look at this point here. Now remember, when I reflected above across the y-axis, I'm sorry, this is the x-axis, excuse me. When I reflected across the y-axis, what changes? Does the x-coordinate change, or does the y-coordinate change? So it's the x that changes, right? So the y-coordinate stays the same. So when I reflect this across the y-axis, the point negative 5, negative 6 becomes the point 5. I'm sorry. Yeah, 5, negative 6, right? So it's the x coordinate that changes. All right, so right here. Oops, wrong. Yep, that's correct. All right, so this point, when it reflects, becomes that point across the y-axis. So notice the distance. The distance stays the same, right? It has to stay the same. So this distance is 6 units, 5 units, excuse me, 5 units. This is also 5 units. Okay? All right, let's look at this point. So this distance is 2 units. So this has to be 2 units. So in other words, the point negative 2, 3 becomes what point? 2, 3. So right here. All right, and then let me use a different color. And so this point here, right here, so when I reflect that across the y-axis, this goes on this side now, right? So these 2 points are on the left side of the y-axis, becomes on the right side. This point's on the right side. When I reflect across the y-axis, it goes on the other side. So the point 1, negative 4 becomes the point negative 1, negative 4. And then here, the point 5, negative 4 becomes negative 5, negative 4, right? So right here. Okay? And so we just connect them, and so I get something that looks like this. Okay, now make sure you're connecting the dots in the right order. Okay, so don't all of a sudden do this. Don't connect these and then all of a sudden do this, because that's not what's happening, right? Because you have this one here. So what I would do is I would go back to what I did first. So I reflect this over the y-axis. I reflected this over the y-axis. Connect those. All right, so let's connect those first. All right, so basically what happens now is this. So what I just did was that this right here represents this reflected over the y-axis. That's the one that represents. Is that clear? That represents this. Okay. Now the next thing we did was this point here. All right. So when I reflect this over the y-axis, I get that point. So I'm going to connect these now. All right. So this becomes this. All right. So this ray, this segment, when I reflect across the y-axis, I get this. Now, it kind of makes sense because the y-axis makes it look symmetrical, right? So if you cover all this up right here, just see where those two segments, the y-axis divides it into two equal parts. All right. So all these distances are the same right here. All right. And then finally, just draw this ray, and you're done. I keep saying ray, I mean segment, and you're done right here. Okay. So that makes sense because when I reflect that across the y-axis, I get this ray, this segment. All right. And so don't forget to label these. So this one right here, the blue one is going to be h of x, and the black one is, put it up here, black one is f of x. Okay? All right. So that was number 5. Okay. Number 6. Let's see what number 6 is. Okay, so number 6. So number 6, you have this graph here. All right. And you want to graph g of x, so that's g of x right here. And you want to graph g of x, I'm sorry, that's f of x right here. You want to graph g of x, which is f of 2x. All right, so this right here is f of x. So we want to graph g of x, which is f of 2x. But you got to remember, so we talked about a vertical stretch shrink, and we talked about a horizontal stretch and shrink. Which one is this one right here, do you think? Yeah, so it is a horizontal one, right? Because remember, if the number's on the outside, that's a vertical stretch or shrink. If the number's on the inside, then that's a horizontal. All right, now you got to remember this, though. You got to think counterintuitive. Don't make the mistake and multiply every x coordinate by 2. Remember, the rule is that when you have a horizontal compression or horizontal stretch, that you take the x coordinate, divide it by b, by whatever you multiply an x by. All right, so that's what we're going to do. So remember, you take x divided by b. The y coordinate stays the same. It's the x coordinate that changes. Okay, so remember what's happening when you do so this is going to be a horizontal. So that's going to be a horizontal. So this is a horizontal. And remember, in one of the lessons we called it C. This handout here calls it B. But basically, whenever you multiply by number greater, where the absolute value is greater than 1, which the absolute value of 2 is greater than 1, this is a horizontal compression. All right, so it's a horizontal compression. So what that means is that your remember, horizontal compression means that you're taking all these points and you're moving it towards the y-axis. That's what that means, compression. A stretch would be where you move it away from the y-axis. All right, so that's a horizontal compression. Horizontal compression. So you're gonna so all points are moved towards the y-axis by a certain factor. Remember, it's not the same distance. Okay, so we talked about that before. It's not the same distance. This is by a certain factor. Okay, all right. Now, so our rule here, remember, our rule is that the point, I'm going to write it down here. So the point xy on f of x becomes, on g of x, it becomes the point. Now remember, the y coordinate stays the same. All right, it's the x coordinate that I divide by this number. So I take each x coordinate and divide by 2. So that's how it changes. All right. Okay, so here we go. Let's take this one here, this one right here. So there's already a dot there. So this, go ahead and label this. So this x coordinate is negative 6, 7, right? Negative 6, 7. So remember what we just said. Now, whenever you do the horizontal compressions, vertical compression or shrink, it's a good idea to do what I'm about to do. Okay, so negative 6, 7 becomes what point? So I take negative 6 divided by what? 2, 7, which is equal to negative 3, 7. So that's the point I plot. So on g of x, the point negative 6, 7 becomes negative 3, 7. So negative 3, 7 is right here. All right. So remember all you're doing is just taking this point and shifting it towards the y-axis. So it's still it's still horizontal. Okay, horizontal compression. You're moving it horizontally. All right. So those were things we talked about in our lessons. On this side, you'll be going this way. Okay. All right. Let's look at this point. Negative 3. This is negative 3, 0. So let's think. Negative 3, 0 becomes negative 3 divided by 2, comma 0, right? Which is negative 1 and 1/2, 0. Negative 1 and 1/2, 0. All right. So negative 1 and 1/2 is about here. Okay. And then let's just go ahead and do the best we can with the curve. This is a curve, so do the best you can. So looks something like this, let's say. Okay. All right. And then, so notice these distances are not the same. Those distances are not the same. So basically what's happening, and I didn't do this a very good job right here, did I? I didn't even go through that point. And I can't erase it. But these distances are not the same. So what happens is that 2 right here, remember when I divide by 2, I'm taking half, right? So basically what's happening is that, see how this distance right here from here to the y-axis, this is now half. All right. See where, let's do this one. See where this distance here, this is now half. Okay. You see this distance here, right here, this is now half, and so on. See right here, this distance, this is now halfway, right? Okay. So that's what we mean by a factor. Not the same distance. Those are not the same distance. You can even see that. Okay. Now over here, so let's talk about 0. Now remember, this is 0, 4. So let's talk about 0, 4. You've had that in previous lessons. So 0, 4 becomes the point 0 divided by 2, 4, right? And 0 divided by 2 is still 0. So the point on the y-axis stays on the y-axis. And so just do the best you can with drawing this. And I could have done a little bit better, but that's fine. All right. So notice that see right here, the distance from the black point right here to the y-axis, this is now halfway. Okay. All right, now this is a ray, so that's going to be a little bit easier. So these come this way. So let's take the point, and remember this is the point right here. This is the point right here, 5, 0. So 5, 0 becomes a point 5 divided by 2, 0, which is 2.5, 0. And so 2.5, 0 is about here. And so I just take my ruler and I just draw a ray. And so notice again remember whenever you're dealing with horizontal compression, you're taking all these points and you're moving it towards the y-axis by a factor. So it's not the same distance. You can tell that this distance here and this distance here is not the same. You didn't move it the same. Okay? So you moved it by a factor. So what happened though is that this distance, this is halfway. This distance here, this is halfway. That's what that is. Okay? So there's the graph. So don't forget to put an arrow here. And so the blue graph is g of x, and the black graph is f of x. And notice though what we had to do here, and you didn't have to, you could have done this to your head, in your mind, but it helps. It helps whenever you're dealing with a vertical compression or a vertical shrink or horizontal compression or horizontal shrink. It's best to actually write out the points. What do they become? Okay, so that was this is number 6. All right, let's look at the next one. So the next one, we have this one. All right, so here's our graph, and so this is f of x right here. So this is f of x. All right, and we want to graph negative 1/3 f of x. All right, so there's two things. So what happened here is that you remember you're going to do the remember this is a vertical. When you're multiplying, when the factor's on the outside, that's vertical. So that's a vertical. And remember, you got to remember, is it a vertical stretch or a vertical shrink? All right, so you're multiplying all the y values. See, you're multiplying y values. So you're multiplying y values by 1/3. So those numbers become smaller. So it's a vertical shrink. So the graph's going to look skinnier. Okay. So it's going to go towards the x-axis by the factor 1/3. Then what does the negative out here mean? Well, the negative is a reflection about. Remember a while ago when we had it in here, then that's a reflection about the y-axis. The negative here is a reflection about the x-axis. All right, so here's our transformations. So we're going to shrink vertically by a factor of 1/3, excuse me, by a factor of 1/3, which means that the y coordinates are multiplied by a third. All right, so whenever you stretch or shrink vertically, your x coordinate stays the same. The y coordinates change, and basically it changes by multiplying each y coordinate by that factor. All right, and then reflect about the x-axis. All right. So if you need to do some work on the side to do these points, then go ahead and do that. So sometimes if you do too much in your head, you might mess up. So for example, see this point right here? I'm going to start with this point right here. Now these are all segments, so it makes things a lot easier for us. So this point right here is -5, -6, right? Okay, -5, -6. And so what I want to do is I want to shrink vertically by a factor of 1/3. So when we shrink, remember we're moving it towards the x-axis, vertical, towards the x-axis, horizontal is towards the y-axis. So you shrink vertically, you're taking the y-coordinate multiplying by a third. Okay, so watch what happens. So if I take that y-coordinate, multiply by a third, so what's happening is this. Let me go ahead and kind of, if you need to do it on a sheet of paper, do it on a sheet of paper. So our first transformation, remember our first transformation is to take each point and multiply by a factor 1/3, meaning the y coordinate though, because this is a vertical shrink. So first transformation is a vertical shrink or vertical compression. And so the x coordinate stays the same as the y coordinate I multiply by a third. So that's what that is. So the point -5, -6 becomes -5, and then 1/3 times a -6. And then 1/3 times a -6, so this becomes -5, is a -2. All right. Now be careful. Don't plot that point, because you also need to do a reflection about the x-axis. But once you get this point, then it's easy. So then the next thing you're going to do is you're going to reflect. So the second transformation. So if you need to write it out like this, then write it out. So the second transformation that you're going to do is that reflection about the x-axis. Reflect about the x-axis. So when I reflect about the x-axis, remember when you take a point, reflect about the x-axis. Keep doing this. If you reflect about the x-axis, the x-coordinate stays the same. The y-coordinate becomes opposite. Okay, so reflect across the x-axis. So what that means then is that I'm going to take the opposite of. So what that means is that xy becomes, when you reflect about the x-axis, becomes -xy. All right. So I'm going to take this point. Now I'm going to use this transformation. So to go now from here to here, so basically I'm saying -5, -2 now becomes what point? So -5, -2 becomes the point 5, -2. Okay? So let's plot that point now. So this is what we're going to plot. So 5, -2. So 5, -2 is right here. All right? Kind of makes sense, because look. So the first thing I had to do was I had to shrink it. So I'm shrinking it by a factor of 1/3. So -5, -6 becomes -5, -2. Then reflect it across the Okay, so obviously I did make some mixed. So whenever you reflect, this is the x-axis. Whenever you reflect across the x-axis, we said a while ago the x stays the same as the y that changes. So notice I put the negative in the wrong place. Sorry about that. So that's negative y. So this becomes negative y, negative 5, positive 2. So that's why when I put that point, I realized something was wrong because look. So when I did this, when I took by a factor 1/3, that becomes this, and then I said I'm going to reflect it about the x-axis, and that's not what was correct. Okay, so you reflect about, so this right here, this point, you reflect about the x-axis, so that becomes a point negative 5, 2. So negative 5, 2 is right here. Okay, so that's the correction. Sorry about that. So negative 5, 2. Okay, so this point becomes this point now. Okay, all right. So let's look at the other one. So let's look at this point here. So that's the point negative 2, 3, right? So negative 2, 3. So remember this point right here, negative 2, 3. So negative 2, 3. So my first transformation says I'm going to shrink vertically by a factor 1/3. Okay, so shrink vertically by a factor 1/3, which means that this point goes towards the x-axis. So that means that this is going to become, remember our rule, x, we multiply y by 1/3, so it becomes 2, negative 2, and then 3 times a third. 3 times 1/3, which equals negative 2, 1. Okay? So this point kind of makes sense and shrink vertically, so it goes here. Now, don't put the dot there because you also have a reflection across the x-axis. So notice I'm going to take this point now, reflect across the x-axis. I should get that point, right? Okay, so what that means is this. So the point negative 2, 1, when I reflect across the x-axis, the y-coordinate becomes the opposite. The x stays the same, the y-coordinate changes. So what I got to do now is plot this point. So the point negative 2, negative 1 is here. All right, so now I'm going to connect those. So this segment right here becomes this segment. All right, so that segment becomes this segment. Okay, now let's go to this point. So this point is 1, negative 4. 1, negative 4. So let's talk about 1, negative 4. So when I shrink it vertically, so I'm going to move this point towards the x-axis. So when I shrink it vertically, it's going to become, remember the x stays the same. The x stays the same as the y that changes. So 1, and this becomes negative 4 times a third, which equals 1, and then negative 4/3. Now remember, negative 4/3 is negative 1 1/3. Okay, so that becomes now. So basically, what happened is that this point, when I shift it, shrink it vertically by a factor 1/3, this point becomes 1, negative 1 and 1/3, which is about here. All right, so basically, it's 1/3 of this distance right here. So that's this right here. Okay, right here, negative 1 and 1/3. But then I got to reflect it across the x-axis, so it becomes 1 and 1/3 right here. All right, so let's go ahead and do that. So the point 1, negative 1 and 1/3, negative 1 and 1/3, becomes 1. Maybe take the opposite of your y, 1 and 1/3. So now that becomes this point. So 1 and 1/3 is about here. So now I'm going to connect those. So I get this. And then finally this one here. You see how it's getting, I shrunk the graph. See how it gets a little bit narrower? Okay. So here you can take this point, which is 5, negative 4. 5, negative 4. And you might say, well, do you really have to do anything? No, you don't have to do anything because remember, 5, negative 4, y'all agree this is horizontal, right? All right. So you know right away where that point's going to be. This point's going to land where? It has to be horizontal, so it's got to land here. All right. So this is what you're going to get. So you didn't have to do all of this because you know this is horizontal, so this is going to stay horizontal. And so I mean, you can go in and check it. So 5, negative 4 becomes 5, negative 4/3, right? Which is negative 1 and 1/3. And so 5, negative 1 and 1/3 becomes 5, 1 1/3. So so basically, remember what's happening. You're shrinking this vertically by a factor of a third. So a third of -4 is 1 1/3, but you're going to reflect it across the x-axis. You get that point. All right. So this is b of x. All right. And so this right here is f of x. So just be careful here. So in our discussion, I wrote something wrong because I was going quickly without thinking. All right, so remember this is a reflection across the x-axis. So the x-coordinate stays the same as the y-coordinate becomes the opposite. Okay? All right, so that was number 7. So this is number 7. Okay, now let's look at number 8. So number 8, we have this, number 8. All right, so we have our function f of x. All right, now remember there are two transformations. You have remember the negative on the inside, so that's a reflection about the y-axis. All right, so we have a reflection about the y-axis. You do that first, and always do the vertical translation last. And then you're going to move up and then shift up 2 units. All right, so that one's easy to do without even writing some things down. So now remember these look like they're curves, but do the best you can. There are no arrows here. So let's start with this endpoint right here. So the point -5, -6. So -5, -6. Okay. So if I reflect it across the y-axis, remember the y-axis. Do y'all agree? Do y'all agree it becomes -5, -6 becomes 5, -6, because when it reflects across the y-axis, the y value stays the same as the x value that changes, and they're actually opposites. So remember, this distance has to be the same as that distance, right? So this is not -5. This is -6, -6. Excuse me. -6, -6 becomes 6, -6. So that's this point here. 6, -6. So -6. This distance is -6. This distance will be -6 as well. So -6, -6, -6, -6. When I reflect it across the y-axis, get that point, which is 6, -6. But then remember, you got to do what to it? You got to shift it up 2 units. So I'm going to take this point, I'm going to move it up 2 units. I get this now. Okay? So I get that point. All right, so now I'm going to, now so I'm doing this in pen, you're going to be doing this in pencil, so just go ahead and just erase it. Just erase it like I'm doing here. All right. Now let's look at this point here. So that point here, so when I reflect it across the y-axis, so that point which is -2, 4, -2, 4 becomes 2, 4. Same distance. So that distance has to be the same as that distance. So just think of it that way if you need to. The distances, when you reflect across the y-axis, those distances from the y-axis to the point has to be the same. So this is 2 units, this is 2 units. See that? But then you got to do what to that? You have to do what to it? Move it up 2 units. So this is your point. So if you actually did this, so just make sure you take this off. Just erase it. Just like I'm doing. Okay? All right. And then this point here, when I reflect it across the y-axis, remember it's on the right side, so when I reflect it across the y-axis, it goes on the left, right? So this distance has to be the same as that distance. So I'm not going to put the dot anymore because all I got to do now is just move it up 2. So I know what to do now. So go across the y-axis and then go up 2. So I get this point. And then finally here, when I reflect it across the y-axis, this point, which is 6, 5, becomes -6, 5 right here. But then you got to move it up 2 units, right? So be careful. So 1, 2. All right. Okay, now you have points all over the place, so let's think about what we're doing. So the first thing we did was we did this right here, right? So here's what I would do. All right, so this right here became this. This right here became this. Okay, so just make the shape about the same, so you're reflecting across the y-axis, so it should look something like this. Okay, so this becomes this. This right here, when you reflect it across the y-axis, see how it kind of opens inward like this? So this is going to open like this. See that? So you see how it's opening towards the y-axis? So this is going to open towards the y-axis also. So don't do this. All right? So don't do that. See, help yourself. It's opening towards the, see how it opens towards the y-axis? So this is going to open towards the y-axis as well. So all you did was you reflected across the y-axis. Okay, so let me just kind of show you this in terms of transparency. So you see this right here? This right here? You're reflecting it across the y-axis. So you're doing this. Okay? So became this right here when you reflected across the y-axis. All right, see how it changed? So this right here, okay, you're taking this and you're going to reflect it across. See how I'm moving it like this, turning upside? Across, and becomes this point. All right, so I'm glad I left these right here. See how you can kind of see where I erased? So it became that. And then we moved up 2 units. So watch, see this point right here? Watch this point. We'll move it up 2 units. 1 and then 2. Okay, so I've got to change a little to make it look right. Okay, so there's the graph. All right, so that's what I mean, that the where it opens inside, when we reflect it, it opens again towards the y-axis. Okay, so what's this one? Then we did this point and that point. So this point became here, that point became here. Is that correct? That's it. I'm just gonna make sure. Yep, that's correct. So then it looks like it's a segment right here, but it's supposed to be a curve. But so just do the best you can. So then that's going to become something like this. Do the best you can. Do the best you can. Let's see. Oops. All right. So be careful. I just realized something. See, this point here, I quickly said that's not true. This point became this, so you got to keep track of things. This point becomes that. So you see where you can make errors like I'm doing right here? So that's things you're going to do. So you have to keep thinking about, well, it's not looking right because that I didn't do any transformations other than any vertical transformation or vertical or horizontal transformation in terms of stretch or shrink. So that should be the same shape, and it looks like it's getting longer. So that's where I realized something was wrong. So be careful. Whenever you're dealing with this, just like I'm doing, and you're going to make that same issue, you got to be careful. Make sure you're locating the right point. So this point is this point was this. So remember, reflect across the y-axis and moved up 2. Okay? So those are the same things that you're going to do. So be very careful. Always look at, well, that's not making any sense. All right? So then just go ahead and erase and then do it again. All right, so things like this will happen. So you got to see this. It's going to happen where you're going to realize, hey, something's not looking right here. So this point here became this point, okay? And that point became this point. So then we get this. All right, so now this looks correct. See this? Okay. And then finally, this point right here, is this point, and that point is this point. All right, so now we have something that looks like it's correct. Okay. All right, so this is, so the blue is k of x, and the black was f of x. So again, as you're going through this, notice when you have your thought processes, you may mess up with all these points lying around where you connect the wrong one. So be careful. Just make sure that what you originally had makes sense. Okay, it looks right. The shape didn't change. You just reflected it and then moved it, in this case, up 2 units. Okay, so be careful. So things like that can happen. It can happen with anyone. So you got to be careful. So this is number 8. All right. So let's look at number 9. So as we go to number 9, remember there are a lot of things happening here. So So as you go to number 9, which is, looks like you have one transformation, another one, and another one, right? So there are three. There are three. So you can easily, very easily mess up here, and hopefully I won't, but if I do, we'll figure it out. Okay? It's the same thing that you're going to do. All right? Because a lot of thought process that goes into this. All right, but one thing you got to know, though, is which one do I do first? So you have a reflection, you have a horizontal translation, and you have a vertical translation. Remember, always do the vertical last. In terms of our rule, we do horizontal first. Okay, so that leaves this next then. All right, so first we're going to do is we're going to shift horizontally to the, remember, with horizontal you think counterintuitive, so it's not to the left, it's to the right. So we're going to shift f of x 2 units to the right. Then we're going to reflect, and this is a reflection across the x-axis or the y-axis? Well, it's the x-axis. Then reflect across the x-axis, reflect that point across the x-axis. Okay? And then we're going to shift down 3 units. Shift down 3 units. Okay? All right. So let's see. Now these are segments. So things will be easy with the segments. So remember, the first thing we do, look at this point right here. All right. So remember, the first thing we do is we shift this point. So every point we're going to move to the right 2 units. Then we're going to reflect across the x-axis, and then we're going to shift down 3 units. Okay. So notice what happens. So this point here, I'm going to shift. I'm going to shift 2 units to the right. Now let me get a pencil so I can erase. Okay, so we're going to shift 2 units to the right. So look, 1, 2. So I get this point right here, right? Okay. Then I'm going to reflect across the x-axis. So -3, -6 becomes -3, +6. So this point becomes this point. Make sure you understand that. Okay? And then I'm going to shift down 3 units. So go 1, 2, 3. So there's my point right here. Okay, so now notice I put that in pencil just in case I have to erase. Let's make sure our thinking's correct. Let's go through this again. So I take this point here, shift it to the right 2 units. So you'll agree that's correct. At least that's correct, right? Okay. Now, reflect across the x-axis. So you're taking this point right here, reflecting across the x-axis. So the point -3, -6. Now remember, when you reflect across the x-axis, the x-coordinate stays the same. The y-coordinates are opposites. So -3, -6 becomes -3, +6 right here. And then we move down 3 units. 1, 2, 3. Okay, so that's correct. So I'm going to go ahead and put that. All right? So remember your transformation. The first thing you do, if you have to write it out, write it out. It helps if you do that. So there are 3 things occurring. All right, so my first transformation, so let's think about this. First transformation was the horizontal translation, right? Horizontal translation. And so when I move horizontally, what happens is that the x-coordinate changes. See, the y-coordinate stays the same, the x-coordinate change. So your horizontal translation was where you took the point xy on f of x, and so then this becomes x, and that was what, 2 units to the right. Okay, so then that's where I add 2 to x. Okay, so 2 units to the right. Oops. All right, so this is where I add 2 to x. All right, 2 units to add to the right, meaning you're moving the point 2 units to the right. So you're adding 2 to x, and then the y-coordinate stays the same. All right, so that's what happens. So notice this x-coordinate right here was -5. -5 plus 2 becomes -3, right? So that's what that's saying. So that's saying this right here, -5, -6 becomes -5 plus 2, -6. And -5 plus 2 is -3, -6. All right, so that's what it becomes. So if you got to write some things down, write some things down. But I think that this one's easy enough to where you don't have to do that. Sometimes writing things like that sometimes confuses people because there's going to be so many points going on. Just intuitively think about this. So it's sometimes easier for people to actually think about this intuitively. So use a pencil, and then you say, okay, well, first thing I got to do is move this point 2 units to the right. Okay, which means you're adding 2 to the x coordinate. All right, so negative 5 plus 2 is negative 3, and the y coordinate stays the same. Then the second transformation says I got to reflect that across the x-axis. So which means that the x coordinate, that this point, the x coordinate of this point stays the same as the y coordinate that becomes the opposite. And so notice this distance is the same as that distance. Okay, so your vertical distances are the same from the x-axis. And then I take this point and I shift it down 3 units. All right, so that's the point I get. So let's do this one now. So now this point, I'm going to move it to the right 2 units. Okay, so watch. 1, 2. So that's from that, right? So then you're going to reflect it across the x-axis. So this point becomes this point. So 0, 0, negative, 0, 3 becomes 0, negative 3. Okay? And then I'm going to shift it down 3 units. So 1, 2, 3. So this is the point I should get. So let's do it again. Make sure it's correct. So here, I take that point, go to the right 2 units. 1, 2. Y'all agree with that? We're okay with that point? Okay. So then you reflect it across the x-axis. So the point 0, 0, 3 becomes 0, negative 3. All right. So that point becomes that point. And then, but I got to shift it down 3 units. So go down 3 units. 1, 2, 3. So there's the other point. Okay, and then I'm going to connect that, and there's my first segment. Okay, that's the first segment right here. All right, now let's do this segment. So this point here, that point, which is 1, 4, negative 4. So I got to shift it 2 units to the right. So look, 2 units to the right. 1, 2. So that's where I'm at. Then I got to reflect that point across the x-axis. So 3, negative 4 becomes 3, positive 4. And then I got to shift it down 3 units. 1, 2, 3. All right, so I get that point here. All right, so I'm going to connect that now. And then this point here, you know that you have this horizontal, so this is going to be horizontal right here. But let's go ahead and look at it. So this point here, I'm going to move it 2 units to the right because that's what it says to do right here. Okay, so 2 units to the right, 1, 2. Then reflect that across the x-axis. So 7, negative 4 becomes 7, positive 4. Then I reflect down 3 units, 1, 2, 3. And so notice I get that point, which is horizontal to this point, and so I get this segment. All right, so for that one, if you were to do all this, it would get so much, you would have so many points all over the place, and you get a little confused. So for that one, I noticed I didn't finish it this way because I knew that intuitively, if I just did what these things are saying, I can get it real easily. Okay, so there's the graph k of x, and this is the graph g of x right here. All right, so that was number 9. So this was number 9. Okay. Okay, let's do one more, and let's do this one. So this is going to be number 10. Okay, so number 10, notice number 10, you have your function, this is a function f right here, and you want to find h of x, which has these 2 transformations. So this will be quick. These are segments. So first thing you're going to do, remember this is vertical, so you do that last. So the first thing you're going to do is you're going to reflect this about the, now which one is the x-axis or the y-axis? That's the x-axis. So reflect about the x-axis. And then shift down 2 units. Okay? All right, so look what happens. So that's going to be easy. All right, so remember you're reflecting across the x-axis. So the point negative 10, negative 8 becomes negative 10, positive 8. right? Now it'll put a dot there and keep it there because you're going to erase it because you also have a shift down. All right, so negative 10, negative 8 becomes negative 10, positive 8 right here. And then I'm going to shift that down 2 units. Okay, so 1, 2. So that's going to be my point. So this point here, when I reflect across the x-axis and shift it down 2 units, I get this point. Okay, so it kind of makes sense. You're taking this, reflecting across the x-axis, so you get this point here, this point right here, and then you're shifting it down 2 units. All right, so then let's do this point. So this point here, negative 6, 2, negative 6, 2, you're going to reflect across the x-axis, you get this point, okay, negative 6, negative 2, but then you're going to shift it down 2 units, so I get 1, 2, I get that point. Okay, so I'm going to put a dot here. And double check. So this point here, reflect across the x-axis, I get that point, and then shift down 2 units. All right, so now I'm going to draw that segment, and I get this. Okay, and then this point here, same thing. You see that horizontal? So that's going to stay horizontal, right? So really there's no work there. You know this is going to now be this, because that's horizontal. This has to be horizontal. All right, and there's no vertical stretch or horizontal stretch or shrink. And then finally right here, so you're going to take that point, reflect across the x-axis, so 6, 4 becomes 6, negative 4 right here. And they're going to shift it down 2 units, 1, 2, right here. Okay, and so you get this graph. Okay, and so that is h of x. That's h of x, and this was what, f of x? F of x. Okay, so that is number 10. So notice I didn't write down anything like this. I just intuitively drew the graph, just looking at these transformations. That's the way you want to do it. Because if you were to do this, I promise you, for each of those, at some point you would have gotten confused. All right. So with these kind of problems, where there's not that many transformations occurring, do it intuitively. It does help. Okay, so that's the end of this lesson.